right, we're going to start into chapter 5, and I would say that chapter 5 is probably the most important chapter that we are going to cover in this class. It has to deal with factoring, and you are going to be factoring in almost every other chapter that we do, and you'll probably be factoring in almost every single other math class that you take from here on out. So factoring is really, really, really important. So we're going to start in 5.1 talking about factoring GCF, greatest common factor, and then factoring using a method called grouping. So let's first talk about what factoring is. Factoring is the process of rewriting one polynomial as a product of two or more polynomials. So now in the past, we've taken two polynomials and we've multiplied them, right? We've distributed, we've multiplied, we've FOILed, stuff like that. Well, now we're going to go backwards and we're going to factor. We're going to figure out if we have one polynomial, how we can make it look like two or more polynomials by factoring it. So factoring is the opposite of multiplying polynomials. Now, a factor is a number or variable that divides evenly into another number. So when I ask you to factor, I'm looking for a number that can divide into it evenly. For example, if I gave you the number 18 and I asked you to list me the factors, well, what numbers divide evenly into 18? 1, 2, right? Because 2 divided by 18 is 9, 3, 6, 9, and 18. So those are all the factors of 18. What about 70? Now, it might be a little bit harder to figure out all the factors of 70, and some of you might have seen a factor tree before, where we can break 70 down into two numbers, prime factors, that multiply to 70. So I always start if it's an even number with 2. So 2 times 35. And now I can break down 35 into 5 and 7. So I can actually say that the factors of 70 are 1, 2, 5, and 7. Well, what other numbers divide into 70 though? Doesn't 10 divide into 70? Because I can multiply these two factors together to get 10. And I could also say that 35 is a factor of 70 because 35 into 70 is twice, right? 2 times. I can say 14 because 2 times 7 is 14. And then I can also say 70 because 10 and 70. So I can divide it into prime factors, and that any product of those prime factors are also factors of the original number. So 70 has lots of different factors. What happens if we start to add variables? For example, if I have an x cubed. Well, we can break down an x cubed into an x times an x times an x. So actually the factors of x, what can I divide x cubed into equally, would be x, because x can go into x cubed, x squared, because x squared can go into x cubed, and also x cubed can go into x cubed. So the factors of x cubed would be x, x squared, and x cubed. Look at this one, it has two different variables. It has an x and a y squared. So if I want to break that down into the prime factors, I can say that there's an x and there's two y's, or I can say y times y. That means the factors are all of the products of any of those prime numbers. So x by itself, y by itself, an x times a y, an x times a y squared, or a y times a y, or a y squared. Those are all the factors of the x, y squared. We're going to add to that a little bit and talk about what we call a GCF, or a greatest common factor. A greatest common factor is the largest number and or variable letter that divides evenly into each term of the polynomial. Finding the GCF is oftentimes the first step in any sort of factoring problem. So looking for a greatest common factor. What number and letter variable can I take out of each term evenly? Let's do an example of that. So example number 1 asks us to find the GCF, the greatest common factor of each of the numbers. So what would be the greatest common factor of 18 and 27? I want to know the biggest number that I can divide into 18 and to 27. You might need to list out the different factors of 18 and list out the different factors of 27 and find the biggest one that they have in common. You should end up getting 9. 9 is the biggest number that divides into 18 and into 27 equally. All right, look at 54 and 84. We want to find the GCF. Again, it might be a little bit tricky to figure out what number divides into 54 and 84 equally. So you might have to go through and do a factor tree and list out all the different factors of 54. I got 2, 3, 3, 3. For 84, I got 2, 2, 3, and 7. So my greatest common factor would be the numbers that they have in common. The numbers that they have in common are a 2 and a 3. So really, their greatest common factor would be 6. 6 is the largest number that goes into both 54 and 84. It's the common factors that they have in common, right? The largest common factor. All right, look at some variable examples. X cubed and x to the fifth. Again, x cubed is really x times x times x. X to the fifth is really x times x times x times x times x 5 times. And so their greatest common factor are the factors that they have in common. I have 3x's here, I have 3x's here, so really the greatest common factor is x cubed. Let's do another one. X to the 8th and x to the 10th. Well, if you think about, there's 10 x's in the first one and 8 x's in the second one. And what's the biggest amount of x's you can take out of both of them equally? Well, the biggest amount would be x to the 8th. So our greatest common factor is x to the 8th. Let's do one with numbers and variables. If I have 24x squared y to the 4th and 36x y to the 5th, let's first start with the coefficients, the numbers in the front. And let's find a greatest common factor between 24 and 36. So what's the biggest number that I can divide into 24 and the biggest number that I can divide into 36? I got 12. 12 goes into both of those equally. All right, now let's look at our common variables. I have x squared and I have an x. What's the biggest amount of x's I can take out of both of them, or their greatest common factor? Well, since this second one only has one x in it, that would be my greatest common factor between the two, just one x. If I have y to the 4th and y to the 5th, this is y, 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 y. This is 1, 2, 3, 4, 5. I have 1, 1, 2, 2, 3, 3, 4, 4. So it looks like the greatest common factor would be y to the 4th. All right, look at F. I have an x squared and an x. It looks like the greatest common factor, the biggest amount of x's I can take out of both would be 1. I have a y and a y cubed, so it looks like the biggest amount of y's I can take out of both evenly would be just a y. So my greatest common factor between these two polynomials would be xy. All right, hopefully that makes sense. What I would like you to do is pause the video and I'd like you to try these two for me before moving on. We're going to add to factoring a little bit, but try these two real quick, okay? All right, the greatest common factor between 10 and 15, the biggest number that I can divide into both of those would be a 5. The greatest common factor between an x to the 4th and x to the 6th would be x to the 4th. So my GCF for those two would be 5x to the 4th. All right, here's one with 3 different polynomials, and we want to find the greatest common factor. So what's the biggest number you can divide into 12 and 18 and 9? I got 3. 3 is the biggest number that I can divide into all 3 of those equally. If I have x to the 4th and x to the 5th and just a 1x here, what's the biggest amount of x's I can take out of each of them? Or what do they have in common? Well, the biggest amount that they have in common is just x to the 1st. So our GCF for those 3 polynomials would be 3x. All right, make sure you practice greatest common factor and factoring out, because that's typically one of the very first things that we have to do anytime we're factoring.